What you are about to discover forever changed the way armies fight on the battlefield, and it all began with something no one could see. February 20th, 1943, north of the Kasserine Pass in Tunisia, North Africa. That morning, German tank commanders witnessed something they could not explain. 5 American Sherman tanks, separated by rough terrain and unable to see one another, converged on German positions with synchronization that seemed almost supernatural. No flags, no flares, no couriers galloping between vehicles. Yet they moved as one organism, each tank covering the blind spots the others could not see, each crew knowing exactly where their comrades were. Meanwhile, inside the German Panzer IVs, equipped with WWII radios, the commanders could barely hear their own company leaders through the interference saturating their outdated systems. The 10-watt German transmitters, considered cutting-edge in the 1930s, could barely reach more than a few hundred meters when the tanks were moving. To make matters worse, most German tanks carried only receivers, unable to transmit. They couldn't report what they saw or call for help. The Americans operated with technology the Germans didn't even know existed. Frequency-modulated radios in every tank, crystal-controlled precision, 25 watts of transmitting power, and clarity that sliced through engine noise and battlefield chaos like a hot knife through butter. 8,000 kilometers from Detroit's assembly lines, the most decisive technological advantage of the Second World War was emerging. It didn't lie in armor thickness or gun caliber, but in the invisible electromagnetic waves linking every American tank crew in ways the German army had never imagined possible. The transformation began on July 22, 1941, when the U.S. Army standardized radio sets known as SCR 508, SCR 528, and SCR 538 for all medium tanks. While German forces advanced through the Soviet Union, relying on radio contact between command vehicles, American engineers at the Galvin Manufacturing Company, later known as Motorola, were perfecting frequency modulation technology that would render German systems obsolete. The engineering team included Daniel Noble, who conceived the military use of FM technology, and Henrik Magnuski, the lead radio frequency engineer who solved the challenges of installing complex electronics inside the harsh environment of a tank. Their creation weighed 82 kilograms and transformed every Sherman tank into a node of the world's first battlefield network. The BC-604 transmitter generated 25 watts of power, 2.5 times the output of the German WWII. Operating in the 20 to 27 megahertz range, it provided 10 preset channels with crystal-controlled stability. The 2 receivers of the SCR 508 allowed commanders to monitor multiple frequencies at once, a capability that would prove decisive in combat. The true revolution lay in frequency modulation itself. The FM technology developed by Edwin Armstrong, a brilliant American engineer, eliminated the interference that plagued older amplitude-modulated systems. While German radios caught every electrical discharge as noise, American FM radios delivered clear voice communication even during artillery bombardments. On November 8, 1942, Operation Torch, the Allied invasion of North Africa, brought American armor to the region. Tanks of the 2nd Armored Division landed near Safi and Fadala, equipped with SCR 508 radios that soon proved superior to German communications. The Afrika Korps, despite being the most experienced armored force in the German army, operated under severe communication constraints. A standard German tank platoon of 5 vehicles included only 1 or 2 with full WWII transceivers, capable of both transmitting and receiving. The rest carried WWII receivers only. They could listen to orders, but not reply or report enemy positions. German tank platoons functioned under rigid hierarchy. The platoon leader transmitted commands that subordinates acknowledged through maneuvers rather than words. When command tanks, easily spotted by their multiple antennas, were destroyed, entire platoons lost coordination. This vulnerability proved disastrous against American forces, where every tank could assume command. The Battle of Kasserine Pass, from February 14 to 24, 1943, provided the first major demonstration of American radio superiority. Though tactically a German victory, the battle revealed capabilities that astonished German observers. Amid chaotic fighting, scattered elements of the 1st U.S. Armored Division maintained coordination across 80 kilometers of battlefield. Tank crews who had never met coordinated attacks warned each other of threats and called artillery support through crystal-clear FM communication. German signal intelligence units intercepted American transmissions and noted exceptional clarity and coordination. The intelligence section of the 10th Panzer Division reported that U.S. units maintained communication at distances where German radios produced only static. More unsettling was the realization that every American tank appeared fully capable of transmitting, not just command vehicles. German WWII radios, operating with amplitude modulation in the 27 to 33 MHz range, suffered fundamental limitations. Their 10-watt transmitters struggled to reach 2 or 3 kilometers under ideal conditions, dropping to mere hundreds of meters when in motion. Every spark plug ignition, every electric motor, every track movement created interference the old systems couldn't filter. By September 1943, American armor reached Italy, where mountainous terrain should have negated radio advantages. Instead, FM technology proved even more valuable under conditions that crippled German radios. The SCR 508's frequency modulation handled valley interference far better than amplitude systems. US tanks coordinated across terrain where visual signals were impossible, and German radios failed completely during the advance toward Cassino, an Italian city. American armored units demonstrated abilities beyond German comprehension. Tank platoons separated by mountain ridges coordinated attacks with precision that German doctrine claimed required visual contact. On June 6, 1944, as Sherman tanks rolled off landing craft in Normandy, France, their SCR 508 radios maintained contact with naval gunfire support, coordination impossible with German technology. But the fighting in the Normandy hedgerows exposed a critical flaw. Tank radios couldn't communicate with infantry radios operating on different frequencies. The SCR 300 infantry radio, working between 40 and 48 MHz, was incompatible with the tank's 20 to 27 MHz range. This communication gap proved deadly in the bocage, the maze of hedgerows and enclosed fields where German infantry armed with Panzerfaust anti-tank weapons could approach U.S. tanks, while nearby American infantry had no way to warn them. American innovations solved the problem in a matter of weeks. Tank crews mounted field telephones inside ammunition boxes, welded to the exterior of their vehicles, wired directly into the internal intercoms. By the time of Operation Cobra in late July, this simple modification had revolutionized cooperation between tanks and infantry. From July 25th to 30th, 1944, Operation Cobra demonstrated the full potential of American radio superiority. The 2nd Armored Division, commanded by Major General Edward Brooks, coordinated more than 200 Sherman tanks through radio networks that enabled unprecedented battlefield control. German defenders from the Panzer Division, an elite German unit, faced an enemy that seemed to possess supernatural awareness. American tanks responded instantly to threats reported by other units kilometers away. Artillery strikes coordinated through tank radios arrived within minutes of identifying a target. The contrast with German capabilities was stark. The Panzer Lehr, once Germany's premier armored division, had been reduced to communication poverty. Most tanks operated without radios, relying on visual signals in terrain where visibility rarely exceeded 100 meters. The few functioning radios suffered interference and limited range that crippled coordination. The irony ran deep. Germany had pioneered the use of radio in armored warfare. Heinz Guderian, the architect of the German Blitzkrieg or Lightning War, had insisted on equipping tanks with radios since the 1920s. His book, Achtung Panzer, Attention, Tanks, published in 1937, emphasized communication as essential to armored operations. Guderian had developed radio communication systems that allowed tank officers to coordinate attacks, understanding that fast-moving armor required reliable communication. Yet by 1943, German tank production could no longer supply the radios demanded by Guderian's own doctrine. German production statistics revealed the crisis. In 1943, Germany produced roughly 5,700 medium tanks, but fewer than 2,000 FUG transceivers. Many of those went to command vehicles and assault guns, leaving regular tank units desperately short of communication gear. Soviet armored forces faced even greater communication poverty. The T-34, despite being the most produced Allied tank, typically entered combat without any radio equipment. Soviet doctrine relied on flag signals and pre-battle planning, with catastrophic results against German forces in 1941. By 1943, the American Lend-Lease program offered some relief. U.S. radios, including SCR 508 sets, equipped Soviet command tanks, but even by the end of the war, only about 25% of Soviet tanks carried radios. The comparison underscored the American achievement. While the Soviet Union struggled to equip a quarter of its tanks with any radio at all, the United States achieved 100% deployment of advanced FM systems. The Motorola factory in Chicago epitomized American industrial mobilization at its peak. Before the war, the company built car radios. Converting to military production required complete retooling and solving unprecedented technical challenges. Each SCR 508 required 2,748 individual components made to strict standards. The BC 604 transmitter contained 474 capacitors and 385 resistors. The crystal oscillators had to maintain frequency stability despite extreme temperature and combat vibration. Production statistics told the story of American industrial power. In 1942, 3,800 SCR 508 family radios. In 1943, 11,400 units. In 1944, 24,000 units. Total wartime production exceeded 50,000 radio sets for tanks. This manufacturing miracle ensured that the 49,324 Sherman tanks built during the war received sophisticated radio equipment, an achievement unmatched by any other nation. The advantages of the SCR 508 went beyond simple frequency modulation. Crystal-controlled frequency stability meant tanks could preset channels before battle and maintain alignment despite combat conditions. German FUG-5 radios, using variable capacitor tuning, constantly drifted off frequency. The dual receiver configuration allowed commanders to monitor both platoon and company command networks simultaneously. Orders flowed down the chain of command instantly, while commanders remained aware of subordinate situations. The BC 606 intercom system integrated seamlessly with the radio, allowing every crew member to alert the commander of threats. Throat microphones and noise-canceling headsets enabled clear communication under fire. Many German tanks lacked intercoms altogether, forcing crews to rely on tapping or shouting. Power management provided another American advantage. The SCR 508 operated on both 12 and 24 volts, automatically adjusting to the available current. The tank's dynamo supply delivered filtered, stable power that eliminated electrical interference. German radios, powered directly from vehicle electrical systems, picked up every spark as static. The tactical advantages of universal radio deployment transformed American armored doctrine. The combat command structure, flexible task forces organized for specific missions, depended entirely on reliable communication. U.S. commanders could improvise battle groups from mixed units, confident they could coordinate through compatible radios. This flexibility baffled German commanders accustomed to rigid organization forced by limited communications. During the Battle of Aracourt in September 1944, the 4th Armored Division faced multiple German panzer brigades equipped with superior Panther tanks. The Germans held every advantage in armor and firepower, but American radio coordination proved decisive. Each Sherman could instantly report enemy positions. Tank destroyers received targeting data from tanks they couldn't see. Artillery observers in Sherman command tanks called devastating barrages within minutes. Over 3 weeks, the 4th Armored destroyed 281 German armored vehicles, while losing only 41 Shermans, a 7-to-1 kill ratio that defied the technical specifications. Throughout the war, German intelligence failed to grasp the significance of American communication superiority. Combat reports mentioned U.S. coordination but attributed it to training rather than technology. A captured September 1944 intelligence assessment stated that U.S. tank units demonstrated good radio discipline and coordination, apparently the result of extensive training and rigid communication procedures. The report completely missed the technological advantage. German tactics never adapted to American capabilities. They continued targeting supposed command tanks based on antenna configurations, unaware that every Sherman could coordinate battlefield responses. They planned ambushes, assuming American tanks would lose coordination when separated, not realizing that radio contact maintained unit cohesion regardless of visual contact. By March 1945, as U.S. forces neared the Rhine River, their communication superiority reached its peak. The capture of the Remagen Bridge demonstrated the speed of American command and control. When the 9th Armored Division found the Ludendorff Bridge intact, radio reports reached 1st Army headquarters within minutes. Within an hour, divisions along the entire front were repositioning to exploit the opportunity. German forces, dependent on telephone lines that American aircraft systematically destroyed, could not respond with comparable speed. American radio coordination created an impenetrable bridgehead defense. Tank platoons from different battalions integrated seamlessly, coordinating fire across radio networks. German counterattacks, crippled by communication failures, arrived piecemeal and were destroyed one by one. April 1945. The encirclement of the Ruhr pocket marked the culmination of American communication superiority. Armored columns of the 1st and 9th U.S. armies coordinated a complex double envelopment entirely through radio communications. Inside the pocket, 325,000 German troops found themselves trapped, partly because their communications had collapsed. American fighter bombers, guided by forward air controllers equipped with radios, systematically destroyed German communication nodes. German army units lost contact with higher headquarters and even with one another. American radio superiority deeply shaped the psychological experience of tank warfare. U.S. crews fought knowing they were never alone. Even when physically isolated, they remained connected through radio waves. German tank crews experienced the opposite, profound isolation. Unable to communicate, they fought individual battles within larger engagements. The strategic implications extended far beyond individual battles. American advances in 1944 and 45 maintained momentum largely through radio coordination that German forces could not match. The Third Army S- across France depended on radio networks maintaining command and control over hundreds of kilometers. German commanders consistently underestimated American capabilities because they could not conceive of the communication superiority the U.S. possessed. Heinz Guderian, serving as Inspector General of Armored Troops, recognized the problem but could not solve it. In a memorandum dated December 1944, he admitted that American coordination nullified Germany's advantages in tank quality. After Germany's surrender, U.S. technical intelligence teams evaluated captured German equipment. Their findings confirmed what combat experience had already shown. German tanks often had superior armor and armament, but catastrophically inferior communications. U.S. Army Technical Intelligence Report number 176 concluded that German tank communication systems lagged approximately 5 years behind American standards. The lack of frequency modulation, limited radio distribution, and poor electrical suppression created critical vulnerabilities. Soviet evaluators reached similar conclusions. The Red Army, given access to captured German equipment, chose to copy American radio designs rather than German systems for post-war development. Production and deployment statistics revealed the magnitude of the American achievement. U.S. radio production, SCR 508, 528, and 538, over 50,000 units. Sherman tanks produced 49,324. Radio deployment rate, 100%. Transmitting power, 25 watts. Crystal-controlled frequency stability, plus or minus 0.01%. Range while moving, 11 kilometers. Range stationary, 16 to 24 kilometers. In contrast, German radio production, FUG-5 transceivers, approximately 6,000 units. Medium and heavy tanks produced approximately 12,000 units. Full transceiver deployment rate, around 20%. Transmitting power, 10 watts. Variable frequency stability, plus or minus 1%. Range while moving, 800 meters to 1.5 kilometers. Range stationary, 3 to 5 kilometers. Communication effectiveness. Average U.S. fire mission time, 3 to 5 minutes. Average German fire mission time, 15 to 30 minutes. U.S. tanks achieving full coordination, 100%. German tanks with complete communication, 20%. The radio superiority of the Sherman tank established principles that still govern armored warfare today. Modern main battle tanks carry communication suites that trace their lineage directly to the SCR 508, digital rather than analog, but fundamentally based on universal deployment and reliable coordination. The rebuilt German army of the 1950s prioritized communications based on lessons from the Second World War. Every Leopard tank produced carried a full radio suite. A German training manual explicitly stated that the defeat of superior German tanks by inferior American vehicles with superior radios proved that information dominance outweighs platform superiority. Modern conflicts validate this lesson. In the Gulf War of 1991, coalition forces with superior communications destroyed Iraqi units equipped with individually superior Soviet-designed tanks, but inferior radios. In 2003, U.S. forces again demonstrated that network-centered warfare defeats platform-centered warfare. The story of American radio superiority in the Sherman tank represents a victory in the electromagnetic spectrum, one more decisive than any advantage in armor or firepower. German tank crews fought their war partially blind to this revolution, discovering too late that every Sherman was not merely a fighting vehicle, but a node in the first battlefield network in history. The SCR 508 radio transformed the M4 Sherman from a competent medium tank into a component of a weapon system that included every other American tank on the battlefield. This transformation proved more decisive than any improvement in armor or gun caliber could ever have achieved. Each Sherman carried the tools of victory, not just in its 75mm gun or sloped armor, but in the 82 kilograms of radio equipment that linked its crew to every other American tank crew. This connection created a collective intelligence that no single German tank, no matter its superior firepower or protection, could match. German forces learned this reality through bitter experience. At Kasserine Pass in the Italian mountains, through the hedgerows of France, and in the final battles of Germany, American tanks displayed coordination that German doctrine deemed impossible without visual contact. The German army never developed an effective countermeasure because it never fully grasped the technological gap. The United States had built not just 49,324 Sherman tanks, but 49,324 networked nodes, the first armored battlefield network in history. The military revolution historians associate with modern network-centric warfare truly began in 1942, when the first Sherman tank equipped with an SCR 508 radio entered combat. From that moment on, warfare changed forever. The side with superior communications would defeat the side with superior weapons. The network would defeat the platform, and the connected would triumph over the isolated. This transformation occurred largely invisible to German forces. They saw American tactical superiority, but failed to recognize its technological foundation until it was too late. By the time German commanders understood that every Sherman possessed communication capabilities their own tanks lacked, the war was effectively decided. The German Army's failure to recognize and adapt to American communication superiority stands as one of the great intelligence failures of the Second World War. Despite countless battlefield encounters demonstrating American coordination advantages, German leadership never prioritized solving its critical communication weakness. They continued building superior tanks that fought as isolated individuals, while the Americans built adequate tanks that fought as coordinated teams. In the end, the electromagnetic waves carried by SCR 508 radios proved more powerful than the 88mm armor-piercing shells fired by German guns. The ability to coordinate, to share information instantly, to fight as one unified force rather than as individual machines. This invisible advantage determined victory more surely than any visible superiority in armor or weaponry. It is vital to remember that, despite fighting on opposite sides, both American and German soldiers displayed extraordinary courage defending what they believed was right. Engineers on both sides worked tirelessly to protect their countrymen. Germans respected American technical ability. Americans acknowledged German tactical skill. Many veterans from both nations later met not as enemies, but as men who had survived the same horror, sharing stories with mutual respect. The final lesson is not to glorify conflict, but to understand that human ingenuity, when directed toward connection and cooperation, will always triumph over isolation. Today, the nations that once fought each other stand as close allies, proving that true victory lies in peace and mutual understanding. And now that you know the invisible secret that decided entire battles, imagine how many future wars could be prevented. Once we learn that connection will always be stronger than isolation.